This is just a sign of how many capacitors, and these are 16 volters, and just a sign of how many capacitors it takes to keep an LED running. And we're going to show you here. See the light there. It's dimming already. It's losing voltage off those capacitors. It's already out because it's below its own load threshold. But it'll discharge slowly. But this is how well voltage rates are, depending upon the load thresholds. I mean, it went from 2.22 to 2.10 in just a few seconds, and that dropped the threshold. And it's actually over 3 volts, and it's actually about 1.3 volt drop over the LED and the solar panel. The solar panel is like 3.5 volts, and this is what you're seeing from the volt drop of the LED and the capacitors. So it's basically out, but you see how the rate is. Just to store up, see, you can't make your load function if it drops too much voltage. However, you charge these long enough, they charge like batteries in parallel. And these are really good. These 1-inchers, they last for years and years and years and years, 20 or 30 years. They're supposedly really good capacitors. And we witnessed it with old cathode ray tubes and old electronics. They lasted forever. We're going to charge it back up here. Watch how fast it charges back up. This is how you use batteries or capacitors instead of batteries on solar and DC to DC generator motors. But you have to switch them with controllers or relays, and they have to hold status on a battery until the battery drops to below its charge threshold of the capacitors. So, because it'll transfer the energy back into the battery if you release it, or I mean back into the capacitors. If you release it from dumping into a battery, it'll go back into the capacitor. So you want to leave it there and balance your charges. But this is how it works. It's charged up now. 2.22 is as high as it'll go right here. So that's pretty much it.
And why that's important is because, one, it is perfectly acceptable to
there it is.
So this can be your tip to toe. I've
Very
been
well.
Here a lot. This is what I bring.
Mostly fully charged.
For my face, for my entire body.
There it is. Okay. So that's it. That's how capacitors work. You need a lot of capacitors in a bank, capacitor bank, to maintain a threshold, and you need to run any of your loads a lot lower than your voltage thresholds are from your power sources, and then it'll run for a really long time over a higher resistance, or even a weak resistance. It will probably run for a while if you have a whole bunch of capacitors. But you know, your typical low resistances are 1 to like 30 ohms. So anything that runs in that range is going to drain a lot of power really fast. So like you need a lot of capacitors and solars. But here's the thing, your capacitors are more important than having a bunch of solar panels. But however, there is a rate at which your solar panels will charge what they call a current add array of parallel charging capacitors. It takes a while. It actually has to climb up like a battery because there's such a current draw on the solar panel. It actually does take time. But as you saw here, didn't take too much time to rise that voltage back up a little bit. So that's basically it. This is how solar panels really work. And this is a thin film solar panel. These are some of the hottest solar panels that charge really hot and fast. But I don't think they handle heat very well. They're more for indirect sunlight. And the other ones are called monocrystals. And these are, I have some large monocrystals that go in the window. They work in the window too. And you just build a big